All right, welcome back. We're going to continue with the AWS Machine Learning Associate exams walkthrough. So today we're going to go over FSX for Windows File Server and a little bit of the other FSX provisions. But before we get started, hit the like button, subscribe, and share to anyone you know who's taking the AWS Machine Learning Associate exam. So let's get started. Amazon FSX for Windows File Server. This provides a fully managed Windows-based file system supporting the server message block SMB protocol and Windows NTFS file system. This service seamlessly integrates with Microsoft Active Directory for user authentication and authorization, supporting access control lists and user quotas typically in the enterprise window environment. So, despite its Windows-centric design, FSX for Windows File Server supports mounting on Linux EC2 instances, providing cross-platform compatibility. That's valuable in mixed environment machine learning deployments. So this flexibility enables Windows-based data science tools to share data with Linux-based training infrastructure, and it supports diverse machine learning tool chains within the same organization. All right. So the service scales to tens of gigabytes per second of throughput, millions of IOPS, and hundreds of petabytes of storage capacity. All right. So this makes it suitable for large-scale enterprise machine learning deployments. The Microsoft Distributed File System, or DFS, that capability enables integration with existing on-prem Windows infrastructure, and it facilitates a hybrid cloud machine learning architecture. So this option provides a fully managed Windows native file system, and it supports the SMB protocol and integrates tightly with Microsoft Active Directory, NTFS, ACLs, and user quotas. Although primarily intended for Windows, Linux EC2s can also mount these volumes. And you see some of the talking points from the main page, right? So let's go to let's. All right. Now we'll go on to high availability. All right. So FSX for Windows File Server supports multi-AZ deployment for high availability, automatically failing over to a standby file system in case of primary system failure. This capability ensures continuous access to critical machine learning datasets and model artifacts, and it supports production machine learning pipelines that require guaranteed uptime. Right? So the service provides automatic daily backups to S3, enabling point-in-time recovery and disaster recovery capabilities. These backups protect against data loss while providing compliance capabilities for regulated industries that require data retention and recovery guarantees. Okay. All right. You'll see some of this information here. I'm saving it to mine. You can see the single AZ, the multi-AZ, the failover process. All right. So next, we'll go into FSX for NetApp ONTAP. All right. So Amazon FSX for NetApp ONTAP delivers the full capabilities of NetApp ONTAP's operating system as a managed AWS service, providing sophisticated data management features that extend beyond basic file storage. The service supports NFS, SMB, and ISCSI protocols, enabling broad compatibility across different operating systems and application architectures. The key differentiating features include data deduplication and compression, which reduce storage costs by eliminating duplicate data and compressing stored information. These capabilities are particularly valuable for machine learning environments where datasets often contain redundant information or where storage costs represent a significant portion of infrastructure expenses. The service supports automatic storage scaling, expanding and contracting based on actual usage pattern without manual intervention. This elasticity aligns storage costs with actual utilization, optimizing expenses for variable machine learning workloads where data volume, um, these volume requirements change significantly over time. All right, and so you'll see some of these off, open all. All right, low latency, the storage scalability, support for performance for database, and then you have the cost optimization. All right. So then you have cloning and snapshot. Let's see if we can find that. All right. Open all. Let's see if I need to open all. Open all. Open all. Okay, here we go. Some snapshots. So, all right. So we were saying snapshots. Okay, so point in time instantaneous cloning enables rapid creation of data sets, copies for testing. This is for testing, for development, and experimentation without consuming additional storage space for unchanged data. This capability supports machine learning development workflows where data scientists need isolated environments for experimentation without affecting production data sets. Snapshot functionality provides efficient backup and versioning capabilities, enabling quick rollback to previous dataset states and supports machine learning reproducibility requirements. So these features are essential for maintaining data lineage and supporting regulatory compliance in machine learning deployments. I'm going to save that. All right. And here's some more specifics about the snapshots. You see the policies for storing files, viewing the snapshot, disabling, deleting, snapshot reserve. All right. So, cross-region compatibility. FSX for NetApp ONTAP supports Windows, Linux, and Mac OS clients. It makes it ideal for heterogeneous machine learning environments where different teams use different operating systems and tool chains. The service integrates with various AWS compute services, including EC2, ECS, EKS, VMware Cloud on AWS, Workspaces, and AppStream, and it provides consistent data access across diverse computational platforms. FSX for NetApp ONTAP brings NetApp's enterprise-grade NAS capabilities to AWS. So it supports the SMB, the NFS, and ISCSI, allowing broad compatibility with the Windows, Linux, Mac OS, and the VMware, the EC2, the ECS, EKS, Workspace, and AppStream. All right, I'm going to save that. Remember that URL. Or you can Google search that title. All right. Next, we'll go into FSX for OpenZFS. So this is ZFS-based architecture, right? So Amazon FSX for OpenZFS provides a managed implementation of the OpenZFS file system, and it delivers a high-performance, sophisticated data management capability. The service supports NFS protocol versions and is primarily designed for workloads migrating from existing ZFS deployments to AWS. The service delivers exceptional performance with up to 1 million IOPS and sub 0.5 millisecond latency. So this is suitable for latency sensitive machine learning applications like real-time inference and interactive data exploration. The performance profile supports applications requiring immediate data access without buffering delays common in other storage systems. Okay. So data protection and efficiency. So FSX for OpenZFS includes comprehensive snapshot functionality and data compression, though it notably lacks data deduplication found in NetApp ONTAP. The compression features help optimize storage costs while maintaining high performance, particularly which for text-based datasets common in natural language processing applications. Like NetApp ONTAP, OpenZFS supports point-in-time instantaneous cloning for rapid environment provisioning and testing. This capability enables efficient machine learning development workflows where multiple experiments can be conducted in parallel using isolated dataset copies. So we'll save that. Go to the next one. Pricing. All right. So pricing components. All right. FSX pricing varies significantly across different file system types and performance tiers. So storage costs form the base component. And this is calculated based on provision capacity rather than the actual usage. Throughput costs apply to higher performance tiers, particularly relevant for Lustre deployments requiring sustained high bandwidth. And then data transfer costs can include the charges for moving data between S3 and FSX, as well as cross availability zone data transfer for distributed deployments. Understand these cost components is a crucial portion for optimizing your machine learning infrastructure expenses. For example, if you choose the appropriate deployment types like Scratch versus persistent for Lustre, this can significantly impact costs, while selecting the optimal storage types like SSD versus HDD that balances the performance requirements with budget constraints. Save this. All right. And you can see each one of these has a little bit more. You can scroll down here, right? But just get started with this. All right. So cost optimization best practices, right? How do you do this? You need to implement lifecycle management strategies to help optimize long-term storage costs. For Lustre deployments, consider using scratch file systems for development and testing while reserving persistent systems for production workloads. Leverage S3 integration to store datasets cost effectively while using FSX as a high performance cache during active processing. Monitor the actual performance requirements and right-size the file systems accordingly. Over-provisioning throughput capacity unnecessarily increases costs, while under-provisioning can create a performance bottleneck that will impact your machine learning training times and overall productivity. Okay. All right. SageMaker. All right. So SageMaker integration. So FSX for Lustre provides native integration with SageMaker, serving as a high-performance data source for training jobs. This integration eliminates the traditional bottleneck of downloading datasets from S3 to individual training instances, significantly reducing the training startup times and improving overall training efficiency. The integration supports both single instance and distributed training scenarios with the file system automatically mounted on SageMaker training instances. This capability enables sophisticated machine learning workflows where large datasets remain accessible to multiple training jobs simultaneously, supporting techniques like ensemble training and hyperparameter optimization that require concurrent access to shared data. Save this. Let's move forward. Okay, let's go here. Let's go up here. Okay. So container orchestration. All right. Is that the right one? It's okay. We'll keep going. Okay. So container orchestration. FSX. All right. FSX file systems integrate with ECS and EKS, which we talked about earlier. And this is for containerized machine learning workflows. So this provides a persistent storage that survives container lifecycle events. And this integration supports modern machine learning deployment patterns where training and inference workloads run in containers that need access to shared datasets and model artifacts. So for Kubernetes-based machine learning pipelines, FSX can be mounted as persistent volumes, enabling sophisticated orchestration scenarios where different pipeline stages share data through high performance file systems. So this capability supports complex machine learning workflows involving data preprocessing, feature engineering, model training, and model serving components. All right, but this I missed the slide for that because there's not AWS does not have a good one for it. So we'll go a little bit into cross-service data flow. All right. Let me see. Yeah, their stuff is down here for compute. Yeah. The querying, Jupyter Lab. Yeah, it's okay. Okay. So FSX services facilitate efficient data movement between different AWS services involved in machine learning pipelines. For example, data can flow from S3 through FSX for high performance processing by EC2s, with results written back to S3 for long-term storage or further processing by downstream services like AWS Batch or Glue. So this integration pattern enables hybrid architectures where different components of machine learning pipelines use optimal storage types for their specific requirements while maintaining efficient data flow between components. All right, so we'll show you. Let's close this. Let's close this. Oh, that was the right one. Sorry about that. Close this. Okay, so let's show a quick tour. Let's go to FSX. All right, so we'll go to FSX in the console. Click create the file system. We can choose either one of these ones, on NetApp ONTAP, OpenZFS, Windows File Server for Lustre. So let's just choose Lustre. We've done this a couple times. Well, let's try Windows File Server. I don't know. You just call it FSX test, availability zone, storage capacity. So it looks like 32 gigabytes minimum. Let's do 64. Okay. Multi-AZ, you select the VPC. That'll be the default preferred subnet. All right. You probably want this private if it's going internal. Standby subnet, secondary failover. Then Windows authentication. AWS managed or self-managed with Active Directory. So you're going to talk about integrations with that. So you have to have your Active Directory domain, DNS server, your service account username, service account password, confirm it to get that all set up in an organizational unit. So that's a lot more complex. Let's go with AWS just to make this simple. Oh, so I'd need AWS managed Active Directory. We'll see. No, it won't let us go. And we don't have one set up. Okay, let's go back to NetApp ONTAP, or I'm sorry, Amazon FSx for Lustre. Um, I think this will, let's double check. Okay, so let's see OpenZFS. All right, so this shows, we can just do FSX test, the SSD or the intelligent tiering for storage, deployment type, single AZ or multi-AZ, storage, let's say 64 gigabytes, VPC, next, see all the things you're editable or not. All right, network, encryption, exports, user groups, and you could create it. We're not going to do that. All right, create the file system, NetApp ONTAP. All right, the file system, multi-AZ or single AZ. Let's see, 1024. Oops, 1024. Throughput capacity, recommended throughput, or specific, right? So you probably want to get, yeah. Why do that when this can do whatever it needs to? VPC, endpoint IP, an unallocated IP from your VPC, or floating. Specify the endpoints to access your file system. So you probably have to provision the floating one, and then the unallocated one is just whatever's available. And then the storage efficiency, go for a recommended. Next, and this will show what's editable, what's not, what you've configured, what you haven't, and then create the file system, which we're not. All right. So then when you've configured whatever storage you're going to have on the system, the next step is going to go to the VPC. All right. So within the VPC, you should have another VPC set up, right? Not the default. You really don't want to do anything with your default. But when you have that VPC set up, you go to the endpoint, configure this endpoint for secure communication between SageMaker and FSX, because it'll typically be required by your security model. All right. So at that point, and you'll need your security group. All right. And from here, you're going to create a security group that'll allow ingress, egress between both of these servers. So it'll allow the communication between SageMaker training instances and FSX mount targets on the appropriate ports. And then, let's see, SageMaker. And then you'll have your SageMaker. All right. Over here, domains, associated domains. All right, let's do SageMaker AI. Down in here to training. All right, your training jobs. And from here, you can configure the training job, right? You have your name, IAM role that's associated with this, go through your algorithm, or you choose one, set up the instance type that'll do the actual processing, and then amount of storage for it, instance count, right? This is how many instances, because if you have to do a lot of processing, and these are large instances, this is going to cost a lot of money. And then your stay alive period, so 60 minutes or 60 minutes. Encryption key, I like an encryption key. And since I don't have one created for this, okay. The max runtime, so how many hours? This is a lot of processing. Whew. 24 hours, that's a lot. Network isolation, then you select that VPC we were talking about earlier. Input, so you'd have the channels for input sources, so you could do a little bit of filters to specify it. Your S3 to have output, have what do you call it? The replicability and distribution. And then you can keep adding more channels. There are checkpoints for configuration. So you'd have basically a saved game would be the best way. And then you could do the specific location for, okay, so ML checkpoints. Okay, so you know where that's actually going to go. And then you have your output target to another S3 with an encryption key. And then the spot training, this will save, yeah, saves on compute, right? That's what the spot instances are for. That'd be a whole other thing. And this would be 48 hours. So you can get a lot of results, but it'll save you money. That's what that's for. And your key value pairs, you know, what purpose, team, call center, contact, any of that stuff. And then you'd link that, right? And then final piece I would add CloudWatch. All right. So from this, you can set up a CloudWatch monitor to track the file system performance and identify optimization opportunities. Sorry, I had some water go down the wrong pipe. Okay, so we have all the FSX types, which you gave you a brief overview for, right? The FSX for Windows file server, right? You can choose the high availability, the multi-AZ or single AZ, Active Directory integration, the storage type with SSD or HDD, and then the backup or maintenance windows. And then we had FSX for NetApp ONTAP. Let's go over here just to see it, just to have it here, okay? All right. So Windows file server, we talked about this one. The high AZ, the single AZ, SSD or HDD. You have the NetApp ONTAP, right? This is, you can do the storage with the virtual machines. You can do the storage efficiency, the deduplication, and the compression. You can have the snapshots and the backup policies and the network access. And then we had OpenZFS, right? And this is where you can select the performance configuration based on IOPS. You can make the snapshots for data protection, have compression settings for the storage optimization, and you have the client access, right? And we already went over FSX for Lustre, which concludes what we wanted to cover. So this is a very useful tool for storage and basically caching and making sure that your machine learning workflows are highly efficient and don't have a lot of lag, latency, drop off, but you get the job done. It's going to cost, but when you have a machine learning app that's in production, you're already making money to cover it. So this is our section on FSX. We will start moving on to some performance tuning into more machine learning in the next lesson. Outside of that, I hope you enjoyed this. Remember to like, share with anyone taking the AWS Machine Learning Associate exam, and subscribe. We'll keep moving forward. Thank you. Have a good day.